Hey, everybody. Our topic today is Microvision, which is our AR interface for teaching about microservices. So microservice architecture is a really cool new trend in enterprise software architecture. It's been around for a couple years now. If you were in Dr. Cherney's software engineering class last semester, we talked about it extensively. The idea is that you can break code into distributed components, which you can then deploy independently. So instead of having this big monolithic service, you now have multiple services that you can deploy out, sometimes with their own database and with their own front end. It's really, really good for cloud deployment, and it brings DevOps concerns into the developer view. So the developer not only has to deal with their code now, they also deal with how the code talks to each other. This leads to a few problems. It's kind of hard to teach this because growing up as computer science majors, we always think about a singular deployment. You push one button in your IDE and it deploys everything. Well, now we're having to deal with all these different multiple deployments. And so static modeling solutions like UML don't really do a good job of talking about this because you have to talk about the interactions between services. Students have to be able to conceptualize this microservice architecture in order to go ahead and implement it. There are some people who have tackled software architecture visualizations different ways. Vincent found some cool graph-based visualizations. UML modeling is pretty standard among computer science, and there's some cool 2D, 3D visualization options. VR visualization actually is a thing, which is really cool. It's used to do visual networks like IoT networks or social networks. And I found a really cool paper, which you can see right here in this picture on the side, which does a good job of modeling connections between different components and objects and stuff like that.
So that brings us to our solution for this problem, and it's called Microvision. So what this is an augmented reality display of a microservice architecture. So if you have some sort of computing cluster that has microservices deployed on it, what this does is give you a view of all of those nodes, an AR view of all those nodes sort of hovering over a table that you define as your space. And then it shows the specific instances of microservices that are deployed on each of those nodes. And then it updates. So if you add a node to the cluster, it'll show you that conceptually, or if you take one out, or if you scale up or scale down a microservice or deploy a new one, it'll show up there. And then it'll draw lines connecting those services and nodes to each other if they make a call. So microservices that are dependent on each other will have a call line between them. And then once a request comes into the system, it'll trace it as a dot along these lines that have connected them, and then you can go back and replay it later. So the point is to give you a good view of what exactly is happening between your microservices. And you can also inspect these requests to see, is it an HTTP request that's being called, or a message queue, or a database call. So this is based on the Microsoft HoloLens platform. And this is just an AR platform. As you can see, it's a headset that projects digital things onto this sort of glasses in front of you. And it's useful because it's already got some, it's already a pre-existing AR platform, and it's got some gestures already defined, like an air tap. So to actually tap into this, the idea is it will connect to the API of whatever cluster you're running your microservices on. So if you have Kubernetes, you can tap into its API to get information about what nodes you have and what microservices are currently running on them. And then your microservices will have some runtime code analysis added on them to see when calls are being made between them. So here are some examples of the system in use. The basic use case is just displaying the nodes and services. You can see we have 4 different nodes here. Each one has some services on it, and our system will draw the lines between them. The idea here is this is a virtual space that's sort of hovering over a table in front of you. And next.
This is where you're going to add a node to a cluster. So you'll notice that you have 2 microservices here, and you're going to go into your command line interface or Kubernetes or OpenShift or whatever and add a new service. And now, kazow, a new service appears connected to the other services that are already in there on this particular node. This is another example where you want to scale a microservice. So you'll notice over here you have 2 microservices deployed, an instance of microservice 1 and microservice 2, but on this other node you only have an instance of microservice 2. So we're going to use the API of whatever you're using to add an instance of that service, And now you can see another instance of microservice 1 appears on node 2.
All right, and then once a request comes in, you'll see it tracked along the lines as a blip, and then it will automatically be recorded that you can go back and play later. And then on the next slide, you can see that once you start playing it back, you can see the different hops and you can step between them to see exactly where your request is going.
And then finally, while you're playing through this request, you can see my very poorly drawn hand here is going to reach out and do the microservice or the Microsoft HoloLens pinching action on this request. And now you can actually see the data that's associated with that request, whether it's an HTTP request or a JMS request or whatever it is. So let's talk through a little bit of the methodology that we used for our experimentation for this service. So we decided that we would take an undergraduate software engineering class at Baylor. This would be comprised largely of college juniors, ages 20 to 21. We estimated very conservatively about 75% male. That, of course, could be greater. But our larger study population is university computer science majors. We decided that a good motivation would be extra credit. Hint, hint, nudge, nudge, any other computer science professors who want to have their classes do studies.
So for the materials, we'll obviously need HoloLens headsets. We say we'll have 4 of them. We'll need PowerPoints and slides for a lecture that we give beforehand introducing the topic. We'll need 1 computer lab with computers and 1 classroom with a projector, as well as a UML modeling tool to do a lab afterwards.
So the design of our study is a 1-by-2 between groups study. What that means is we have 1 factor that we're going to apply different levels of, which is the method of learning about microservice architecture. And between groups means that we're going to have 2 different groups that are doing different things. So our independent variable, obviously, is the method of learning about microservice architecture, but our 2 dependent variables are the understanding of microservice architecture and the satisfaction while using either interface, which we're going to talk a little bit more about.
So for the procedure, we're going to have a 1.5-hour class. The first 45 minutes, both groups will get the same lecture about microservices, and this will be prepared beforehand. And then after that, both groups will split. 1 group will go and have a more traditional lab where they'll do some UML modeling exercises. They'll just have different scenarios that they have to display of how a microservice architecture is laid out and deployed. And then the other group will go to the Microvision lab. And they will also get some scenarios of, here's some requests that come into this system. Here is what happens when you scale up or scale down a microservice, when you add a node, but they'll be viewing it through the Microvision headset. And then afterwards, we'll give them 2 surveys. 1 is a traditional knowledge quiz consisting of 15 questions, multiple choice and true or false. And that'll just be testing their comprehension of some microservice concepts. And then also a satisfaction questionnaire of their method that they were assigned of learning. So for the knowledge quiz, here are a few sample questions. The first 2 questions are related to the relationship between microservices and nodes and how they interact and can be deployed. And then the third question is about the interaction between them, talking about the different kinds of calls, asynchronous or synchronous between microservices.
And then we get to the satisfaction questionnaire. So this is on the 5-point Likert scale, which is a traditional scale. It's actually used in another paper that I viewed for computer science questions by looking at these 3 questions where you ask the user whether they enjoyed using the system, whether the system was helpful in learning material, and whether they would use the system again if they had to study the material more, just to kind of get an idea of how well they liked using the system.
So in conclusion, this Microvision is intended to make learning a complicated concept like architecture a bit easier. So for that reason, we chose a user study in a real classroom environment to see if it was actually useful in making this concept more approachable. And if this works out for this concept, it could be applied to other software architectures, as well as expanding more dynamic runtime features to see what exactly is going on in your programs.